So, a traffic officer monitors the rate at which vehicles pass a fixed point on the motorway. When the rate exceeds 36 vehicles per minute, he must switch on some speed restrictions to improve traffic flow. So we've got suggest a suitable model to describe the number of vehicles passing the fixed point in a 15-second interval. Well, the only distribution that you will have learnt that applies to this is the Poisson distribution. Poisson distribution deals with events that happen singly and independently in a passage of time or length of interval. This is a passage of time, so Poisson distribution is what we need. Now, the traffic officer records 12 vehicles passing the fixed point in a 15-second interval. We need to test at a 5% level of significance whether or not we have sufficient evidence to switch on the speed restrictions. So if we go down to a 15-second interval, then the known rate would be lambda equal to 9. That comes from the amount per minute divided by 4 to come down to 15 seconds. So lambda would equal 9. Now, if it's changed and we have got 15, well, we may well think that lambda is greater than 9. So I'm going to set this out in a one-tailed test. So I'm going to find out then what the probability that given that we get the probability that x, our variable, is greater than or equal to 12, given that lambda is 9. So I can find that information out from the tables. Now if I go into the tables, I can find out the probability that I can do this by 1 minus the probability that x is less than or equal to 11. So the tables tell me that probably that x is less than or equal to 11 is 0.8030. So if I subtract this from 1, I'm going to get 0.197. Now at the 5% significance level, this is insufficient evidence. So then we have to say that our conclusion is that there is insufficient evidence. So we accept H0. And there is no evidence to suggest we need to speed on the switch, the speed restrictions. And that's the answer. That gets you the 6 marks here.